Hey peoples, today we're working on the question of whether or not a linked list has a cycle. So we're given a head of a linked list, determine if the linked list has a cycle in it. What's a cycle? There's a cycle on a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS, position, is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. Return true if there is a cycle, otherwise return false. So it looks like we have two outputs, true and false. Can you solve it using constant memory? Oh, all right, so here's some examples, right? Start off here, and what we notice is like if we were to go to the next one, we would always keep going in a circle, right? This one's next property, this one's next property, go next, and now we go next over here, now we go next, then we go next, over here again, next, next, next. So basically what's happening is a cycle seems to be like a loop, an infinite loop. Like we can never reach none, right? Like you usually can on linked lists where you have like 1, 1, 2, 1. And that's not gonna happen because here it's more like 1, 2, 3. And then 3 points back to 1, right? Or to 2. So this one here has a cycle, it's true. This one here has a cycle, it's true. This one here does not have a cycle because it does not have a next property pointing to like another node, right? So let's think about some cases, right? So let's say like we have our head, right? It said that we're given a head, right? What if our head is none, right? Which is like the most basic case. What if our head node is none? Is none a linked, is that a cycle? I don't think so. That's gonna return false. And shout out to my terrible drawing. That's gonna be false. Okay, so cool. Now let's think like, okay, what if we have like one node, right? What if we have like one node, like this example right here? Why is this one false, right? Why is this one false? Well, because we have a node that says 1, and then its next property, right, is none, right? It doesn't have a next property, so its next property is none by default. As we see here in the class constructor, by default, next of the node is none, because that's how linked lists work. So here we have none, right? So what does that tell us? It tells us that when we get to this right here, we can also think of it as case 1, right? So right here, this basically tells us, right? My drawing is terrible. So here what this basically tells us is if we are able to get to none in a linked list, right, then it's going to give us back false, right? Because this one here, the next pointers are pointing at somewhere in the linked list again, and they're going in a circle. So let's check that down. If we get to none, we know that we do not have a cycle, right? Because it ends, the linked list ends, it has an end. Okay, so now let's, this is a case of a cycle, it's true. Let's go to this case, right? So what we can do is we can have a slow pointer and a fast pointer. And so we have like a linked list, right? Let's pretend this is a linked list here. It's obviously terrible drawing, but whatever. So this is basically what they drew, right? So then let me go so I can type stuff, right? So here, let's say we have like a slow pointer starting off here, right? We're gonna have a fast pointer that advances quicker, right? And we want our fast pointer to start one ahead of the slow pointer. Maybe like why? Because if you were to look at this case, right? We have a slow pointer, right? And then a fast pointer here. Then we know that this list ends because fast starts here, right? And we're gonna want fast to do is we're gonna want fast to jump like to here. We're gonna want fast to go 1, 2 steps ahead. meanwhile slow is going to be moving one node at a time. And basically what that's going to allow us to do, so slow is going to go here, then fast is going to jump here. If we were to have slow and fast and it's starting from the same position, then fast would have to jump to the second node, right? Which just doesn't exist. So we want fast to start one node ahead of slow. So yeah, I think that made good sense, that explanation, because we're going to have fast moving two nodes at a time here. And if we have our slow, if we have our head, right, but then we don't have a third node, right, we have a second node, then fast is not going to be like a valid value, basically. We need it starting at somewhere where we can like actually work with the data, because everything has like a single node, right? Its next property, let's say we have a single node, right? Its next property will be none, right? So we're dealing with only one node and its next property is none. We're going to have fast being the next property, right, of the node. So that way we are always working with valid values, if that makes sense. If not, maybe we'll see in the code. So we're going to move this one here 2 ahead, and this one here 1 ahead, right? Now here, F, we're going to move 2 ahead again, right? So we're going to move all the way 1, 2. So this is our next stop, right? F. And then S was here, right? Because we moved it ahead of 1. So then S is then going to go here, and then it's going to be S, right? So now S and F are in the same spot. So we know that this is a cycle, right? So how do we code this out? We can say like, we need our slow pointer, right? Slow is, well, we first have to do with the first case I made, remember, where we didn't even have a head node that was valid. So we return false in that case. So we say if head is none, return false, right? In that case, there's no cycle because it's an empty list. So we're going to say slow is equal to head, yeah. And then we're going to say fast is equal to head dot next, right? Slow is equal to head, right? Fast is equal to head dot next, right? Which is this value right here, basically in the class constructor. So if we have a single node, we're always working with valid values, right? Because this next pointer is always going to be pointing to none if we only have a single node, right? So this right here makes it work for a single node. So that way we're working with all cases properly, right? So now we're going to say, and it's so important to be able to break it down into like being just a single node, right? Don't start off looking at this problem. Start off thinking about a single node, right? And then the single node, of course, has the next property. You just can't stress that enough. So while slow is not equal to fast, right? Because if slow becomes equal to fast, right? If slow becomes equal to fast, then we know that we have a cycle, right? Because they met. So we're going to say if slow is not equal to fast. So then what was the condition again? So yeah, we can't have fast being none, right? And because fast is moving 2 at a time, right? You can have several cases, right? We can have the case where fast is none. And then we can also have a case where we have 1, 2, none, right? So this right here is slow and fast, right? Now fast is going to want to jump ahead 2 times, right? To the next, to this one right here, it doesn't exist. So we need to account for this one, which is actually fast dot next because of the pointer. This is a fast dot next property, right? So if fast is none or fast dot next is none, then what are we doing? We are returning false, right? And then we want these to keep moving forward. So we're going to say slow equals slow dot next, and fast equals fast dot next. And if slow becomes equal to fast, then we know to return false, right? Now we know to return true because we've exited the loop because we've checked and made sure that this condition was not true. So they didn't meet. So we do have a cycle and it is true. And I'm going to submit this. And nice, it worked. So, yep, that's all I have to say about that.